Okay, so young and slim, this lesson's for you. We will cover two sections today. 4.3, ratios of areas of similar plane figures. That's page 96. You guys need to open your textbook and follow along with me because I will refer to the textbook all the time. And section 4.4, ratio of volumes of similar solids. 102. Okay, so basically ratios of areas and ratios of volumes. Okay, look at the areas. If you look at page 96, you see similar areas: triangles, squares, rectangles, circles, octagons, and other polygons. So basically, when you have similar areas, okay, you have the area of one over the area of another is equal to the corresponding size squared. Okay, let me show you. So you have the area 1 over area 2 equals to corresponding side A over B squared. Okay, where A is one side of this figure and B is the corresponding side of this figure. For example, these are two similar triangles. All angles are the same, right? Corresponding angles are the same, just one is bigger than the other. That's why they are similar. They're not congruent. If they're congruent, then all the sides will be the same and they will be the same size. Here they're different in size, but same angles, corresponding angles. So if this is area 1, this is area 2, and this is side A, this is side B, then we have A1 over A2 equals to A over B squared. You have to keep in mind that this side must go with that side. Okay, you can't just put this side over another side that is not corresponding. They have to be corresponding sides. And then one over the other, you square them. So this is your formula. For example, you have these two similar rectangles. Okay, they're similar because the sides are in proportion. Okay, as you can see, 15 over 9 is equal to 20 over 12. 20 over 12. Okay, both are, let's see, 5 over 3, right? 5 over 3. Both of them. Okay? So anyway, they're similar rectangles, so you know that area of 1 over area of 2 equals to, now you can do 9 over 12 or 15 over 20. It's the same thing. 9 over 12. Right? Corresponding size because 9 goes with 12. So that's pretty easy. And then 15 goes with 20. So you can have area 1 over area 2 equals to 15 over 20. Alright. So area 1, that's easy, is 9 times 15, right? Whatever that is. Area 2 is 12 times 20, whatever that is. So that's easy. Now volume is the same thing. For two similar solids or volumes, so volume 1 over volume 2 is equal to A over B. Same thing, A over B, but this time it's not square, it's cube. Okay, A over B cubed. That's it. There's no mystery. Very easy. Okay, example. So you see these two similar volumes for the pyramids. So volume of pyramid 1 over volume of pyramid 2, you know, the small one over big one is corresponding size, right? 4 over 6. 4 over 6. You have to cube it. Cube it. That's it. Okay? So normally they will give you one of the volumes. They give you volume 2. Then you plug in volume 2, then you can solve for volume 1. Or if they give you volume 1, then you plug in volume 1, then solve for volume 2. So just use this formula. So for the area is the corresponding side squared. For the volume is corresponding side cubed. Okay, that is all there is to it. 4.3 and 4.4. Now let's look at an example. See, example 12, page 104. You look at example 12. Okay, you see two cones. The big cone, outer cone, and the smaller cone. The water cone inside. The water inside the bigger cone. Okay, they are similar cones. Right? Everything's the same except one is bigger than the other. Okay, so you know that the sides are in proportion. Alright, it's given the radius of the big cone, so you can find the volume of the big cone. Remember, the volume of a cone is equal to 1/3 base area times the height. Okay, base area, this is a circle, so area of the circle is pi r squared. So you know pi and you know r, 7.5, so square that one. So you get volume, let's call it volume of the big cone. Volume big equals to 1/3 base area is pi r 7.5 square times the h. The height is 18. That's the height, 18. Okay, that's the big volume. Okay, now volume of small we don't know because we don't have the base area for the small, but we can use our formula to find out. Volume of big over volume small equal to corresponding size, right? The side of the big over the side of the small cube. Remember, it's cube for volume, for similar volumes, and it's square for areas. Okay, so you plug that in, plug that into volume big. The side of the big is 18. Side of the small is 12. Corresponding side, in this case, is the height. Corresponding height. You can use radius also if you have radius, but in this case you have only one radius. You need two corresponding sides. So you will have 18 over 12 cube. Then you have this. You have everything. Then solve for volume of small cone. Okay. Stop.